Hello. So we are doing a more casual stream today. Had not even a stream, just doing a quick recording today. Had some technical difficulties with Python and Windows Subsystem Linux and all that good stuff, and so we've found some solutions. And let's get ourselves into a working environment, and then we are going to build a paint program with Python. Cool. So what we're doing is we are ditching Windows Subsystem Linux because Windows Subsystem Linux does not work on for GUI applications, which is what PyGame is. So instead, we're going to switch over to Commander, which gives me most of the Linux commands that I like: ls, pwd, which or what. Just basically all the commands that I use anyway. Um, so we are going to install this. I'm just going to, actually we can just show what's happening. Drop it in here. Cool. And while that's going, we are going to install Python. I think unfortunately I actually installed Python on a different user, so I'm pretty sure what did I use? pipenv? Yeah, so historically Python used pip and virtualenv separately, managing requirements.txt and all that kind of stuff, and pipenv does it all automatically. So let's start with this once this finishes copying so we can open Commander. Take a little sip of coffee real quick. Also, we'll open up the PyGame docs. So the first thing we want to do is the getting started. We'll want to install PyGame. And then we'll want to try out their demo application. And they'll be good to get coding. I'm like looking over at my other screen to see if there's anyone chatting, but we are not doing chat today. So there's actually no question of the day's comments. Anyway, if you're watching on YouTube later, feel free to post down below and I'll reply if you have any questions. Alright, so that's in. We'll run that anyway because we trust it. We'll unblock and continue. We'll pin this to the taskbar because we're going to want to keep Commander around. Okay, so okay, don't have Python at all. It's probably just going to be that executable. Oh, here we go. We'll download an installer. Add it to our path. Cool. Oh gosh. Oh, what did I just click on? Okay, hopefully it was nothing. If I could type. Nope, so instead of believe, we're going to have to restart. Cool. Okay, so we got Python, and now hopefully we also have pip, which we do. So now we want to pip install pyenv, or pipenv, sorry. All right. So now come back to where we left off yesterday. Cool. Let's start again. So pipenv. What do we got? What are our commands? Pipenv. So I believe it's like running pipenv install, and then we do PyGame. Should install PyGame. All these windows finish popping up. It's doing a bunch of good stuff. Virtual environments and things like that. So we'll now run the example, which should hopefully work. Let's bring up the terminal because my camera's in the way. No module PyGame. Did I not just install it? Okay, I'm confused. What's that command? There we go. Cool. Could have swore I didn't have to do this step. I like ran this complete on my other account, and this worked like immediately. Anyway, so then we can we should, if we don't need this anymore. Are there next steps? No. Okay. This is the getting started. Install, introduction. Okay. Let's see. All right. So we want to make a paint program. So we want a canvas. What are our goals? Oh, let's make it in here. Actually, let's just code this whole folder. Cool. So we want to set up PyGame, call it skeleton. Then we want to, oh man, I have an itchy nose today. We want to set up I think the goal for today is to be able to like just draw a rectangle and have that rectangle output to G-code. G-code is the output a set of instructions that I can send off to the 2D plotter. So we'll want to set up a config to match 2D plotter. Today is more of like a proof of concept, or at least understanding all the steps that it would take to do such a thing. Cool. All right. Whew. All right, so let's jump in. All right, so first we'll import the Python package, PyGame package. Cool. All right, so we'll init. We don't need fonts. Okay. Wait, what are next steps? All right, maybe let's. Here we go. Okay. Screen of size. Oh, this is interesting notation I've never seen before. Can I not bring up? Oh, whatever. Huh. Interesting. Okay, so we'll have const plotter width. My plotter is 400 millimeters by 400 millimeters, which I'm not sure. I think the exact granularity will be TBD. We'll just say for now that our width and our height are 400 each. And this will end up being the amount of steps stepper motor can turn to cover the entire width height plotter. So stepper motor is basically what we are using to drive. Let's switch over here actually. Cool. So if you look here, these are two stepper motors, and underneath there's a spinning wheel, which is attached to these belts that you can see here, which is causing this to move. And each stepper motor can as a very precise movement called steps. And so one step is the minimum amount of rotation that a stepper motor can take. One of these stepper motors, to give you a better idea what the other side looks like, it looks like this. And each stepper motor that I have here has a max of 200 steps per, or it's 200 steps per full rotation. So figuring out this value will end up being the number of steps it takes to cover the x or y direction. So we'll have to come back and actually figure that number out later. Cool. Okay, so our screen. Oh. Go right here, and this will be plot our width, plot our height. Okay, so let's see. So first we were importing and initializing PyGame. On line 8, we create a, a screen. At line 10, we load our ball. Okay, so this loop will run forever. We don't need all of it. So while true, all right. So if our event is quit, we'll quit. Otherwise, we'll do things. But I think for now, we just want to fill the screen with black. Refresh the screen and see if this works. Why can't I bring up the terminal? Control Shift. Okay, interesting. Whatever. Right, because pipm shell. Oh, because they're in Windows System sublinks, which we oh gosh. Oh my gosh. Don't want any of these actually. So we'll just use this. Argument mon. Okay, so this should actually be a tuple. Cool. Black is not defined. That is true. Black is 0, 0, 0. Okay. Cool. There's our 400 pixel by 400 pixel window. Close it out and it closes. So we've created the skeleton. Okay, let's set my email off screen. Cool. All right, so we've committed. Now we can get push. Oh, come on. All right, so it looks like I need to reset up Git again. All right, we can figure that out later. Okay, so that's it for this example. Okay, so this looks like we want to do next. Come back in our to-do. That's, I think, more or less actually done. I'll need to, I don't have my platter set up to even really do any more than that. Cool. So I wonder if this function can click and draw. All right, so let's see. Let's do this. Let's draw a white rectangle. So draw rect takes a surface, which we called screen, takes a color, and it takes a rect rectangle. How is a rectangle defined? Where does one import rect from? I wonder if I can just type these in. Let's see. Oh, that's not what I want to do. We want to Python main. Oh, okay. That was easy. So we probably don't actually want to draw a rectangle. Because we don't want it to fill. As a fourth, the width argument. Let's go 2. Close this out, and hopefully that'll be rect takes no keyword arguments. What? Oh, okay. Sweet. This is proving to be a bit easier than I expected. Okay. This next step is actually gonna suck. Or not suck, but it's gonna be the most difficult. Okay. So I think what we have to do, what do we have to do? I think we need to make a function. Oh, they need to be able to draw it. drawing. Okay, so we'll remove this line. If event type equals quit, okay, so we need to nest inside this if block. What do we got? We'll start with if event.type equals mouse button down, and that comes in. I'm gonna guess this is PyGame locals. I don't see this being listed anywhere else. All right, so if we run, whoops. Mouse button down. Let's see where this comes from. I'm going to assume that it comes off of this. So we'll paste this in here. Come back and run it again. Cool. Okay. So if mouse button down, I want to declare an isDrawing variable. So delete this line. Set isDrawing equal to true. If event.type equals mouse button up, isDrawing equals false. I'm trying to think of how we want to feed those variables. Let's just start drawing first. Okay, let's see what we got here. Alright, so we can unnest these. Else if the event type is mouse motion and isDrawing. We'll get the mouse position, last position. I don't like mental mapping. I like to just write things out. So call this last cursor position. So we'll draw black. We want to draw white since our canvas is black. All right, let's see what this gives us. Last cursor position is not defined. Oh, that is true. All right. White is not defined. That is true. These are consts, so they should be all caps. And they should indeed be tuples. Okay. So black, white. That does nothing. Can I not do the double? Does this really have to be in an if block? Oh, there was a... Nope, just not doing anything. All right, let's just copy fully what he has. Interesting. Okay, so is it the ordering of events that matters? Oh, I think it does. I bet you this won't work. It does. Huh. Okay, well, interesting. I think we also want to do on mouse up, set last position to none. That should fix that little bug where if you clicked, it would connect the lines from the previous, yeah. So if I comment out this line, come back here, close this out, do that again, you'll see that I'll click a draw line just fine, but if I click again, it connects. So we need to get rid of last position. Cool. Okay. So we got clicking, painting, working. All right, so now to draw a rectangle. So basically, what we need to do is to draw a rect. This is going to be hard because I want you to be able to visualize it as you draw it. And then when you let go, have it only show the one that you were drawing. Let's see. What if we try... This might end up being a class of sorts, but we'll see how we can do. All right, so on mouse button down, we want to get the mouse position. A mouse position will become will equal draw rect, we need we don't want current rect. Current top, current left, current width, current height. Okay. So looks like mouse position is a tuple, so when we start clicking, current top will equal, and current left will equal the mouse position. I think these are backwards, actually. Okay. Okay, so we don't want this anymore. We're going to get the mouse position, and we are going to set the current width and current height. No. There should be start top and start left. And then we'll have current left, current top, current left. And so when mouse motion, current top, current backwards, current left will equal that. And then we want to draw a rect with start top, start left, and then the width will now be we got to draw on the screen. Oh, and then we need our color, so we'll draw black. And this needs to be a tuple, and then a width. Okay. All right, so let's see. So we're going to want to subtract current top minus start and current left minus start left. I might have completely butchered the math here, so we'll see what happens. I bet you it's not going to draw where you think it's going to draw. Oh my, okay, cool. Let's actually look up what draw rect actually takes for arguments. Left top with height. Okay. That's backwards. Left top with height. Okay, cool. And mouse position PyGame.mouse.get position returns over X and Y. Okay, so that should be correct. That looks good. We want it to clear the screen though. Clear surface, I should say. is blitting? This is what we want. Blit everything on the screen. Blit. Okay. The term used for rendering objects is blitting, which is where you copy the pixels belonging to said object onto the destination object. So to render the background object, you need to blit it onto the screen. Oh, interesting. Okay, she shouldn't over blit. We don't need a fast program though, so okay. So that should get rid of our background issue. Cool. That's pretty fast. That's nice. Okay. So now on mouse up, we'll want to save these values. We don't need this. Don't need this. Okay. And I think we want to reset these as well. But anyway. All right. So we'll have a little array called completed rectangles. And we'll want to add these values to that so that we can then draw them. Cool. And then we'll want to draw each of those. Oop. Oh no, we want to actually copy these values and put these in here. Whoops. Okay. So, draw the rectangle. Draw. Oh, that's cool. All right, so on closeout, let's see. That little flash up at the top, it's kind of annoying, which I think that guy solved in the previous problem. I think we'll want to set start top. I want to reset these all actually on mouse up. I think we'll actually want to okay, I don't think we want to do this. I think actually we want to set current top and current left. Cool. So that should get rid of the jumping to the top. Cool. Sort of. Oh, because this should be start top. All right. Cool. That is nice. Okay. It doesn't even get slower. That's awesome. Okay. So, last up, I think we want to just get at print completed rectangles. Let's commit what we have right now. Cool. So if we start drawing, we should see something get outputted that is roughly 0, 0, and then 400, 400 to the terminal. Oh, because it gets stuck in the while loop. Okay, whoops. We don't want this print here. We want this print. On mouse button up, we'll print it out. Cool. Nice. And then if we draw here to here, we should see one that's roughly 0, 0 up to 400, 400, which we do. Okay. This might not actually be as hard as we imagined. Okay, interesting. So, I think basically all we need to do is so we could add circles, completed lines, all those different things to these arrays. And, oh, we could do an undo function super easily by just deleting the completed rectangles. Oh, okay, hold on. Getting a little excited real quick. Okay, so hitting escape should stop you from drawing the current square, and undo should undo. Cool. There's the list of all the keys. Okay, so if event type equals key down, okay. Huh. Okay, so we have modifier keys, which we're going to want to do CTRL Z. Okay, so I think we want just this else if in here. Let's just add undo. I don't want, and okay, I'm missing. Yes. Okay, so I think we want this. Oops. Okay, so in that case, if writing different languages, if the length of completed rectangles is greater than 0, complete rectangles dot. Oh gosh, is it pop? I believe it is. Okay. So draw it, hit Control Z. Wait, this just works. Let's try this again. So it's getting in here. So this only works when I initially start? No, it just doesn't want to work at all. Oh, this state is, I'm very confused with what's happening. Okay, that's exactly what I'm expecting to happen. Okay, it's empty. It's got a length. It's got a length of 2. We should hit Control Z and one of them should disappear, but it doesn't get removed. Okay, so it's actually working. But wait. Okay, this is bizarre. If I hit Control Z twice, and I bet I draw again, it's gonna remove. It's gonna. What? Oh, because this is always keeping one around. So we'll only actually want to draw this if is drawing. That should fix it. Okay. Nothing. 1, 2, undo, undo. Oh my gosh. Infinite undo as well, which is very cool. And then I can just... That's satisfying. Cool. All right, let's get rid of our chaotic print statements. Okay. That should hopefully keep working. Cool. Don't need this. Don't need this. Cool. All right, and then we wanted to output G code. So I think when you close this, done does not fire. Interesting. Oh, so it's never going to get here. We're probably going to actually want this. I'm going to close out. Done. Okay. So in here we want an output G-code function, which we define above. This will take completed rectangles. Okay. So for left top width height in completed rectangles, so our first line will be from maybe we'll just find this better as top line. So the top line of a rectangle will be from left top. So if we're just drawing lines, we can make this where each of these pairs will be X and Y points. So it'll start in the left top, and it will continue from top, but it'll be left plus width. These are the kind of the instructions that I will need to send to the plotter. So the bottom line will be left bottom. There, cool. Left line will start at left top, and it will go to stay at left, but it'll be top plus height. And then the right line will be left plus width, left plus width. Cool. So let's launch our PyGame, see if it works at all. Output G code was not called with completed rectangles. That is true. Oh gosh, where is it? Here. Run it again. Draw lit. Bottom is not defined. Where did I write bottom in here? Okay, whoops. Okay, so the bottom line is left top plus height. I expected in my head that I did something wrong because I was like, when I got to the last thing, I was like, I don't think I've. Anyway. This should work. Cool. Alright, so something that makes a little bit more sense. We'll draw lines from. Oh gosh, if I can grasp. Here to there. This should be easy to understand. So our top line goes from 1,3 to 403. Our bottom line makes sense. Our left line also makes sense. And our right line also makes sense. Cool. This feels good. This feels good. This feels committable. This feels committable. So got rid of cancel. Finish our proof of concept. Cool. That was a quick stream. That feels good. How long was that? That was 1 hour. Awesome. All right. On that note, thanks for joining me, and I will see you next Tuesday.